So I think I'm gonna try to avoid talking about RS2D too much in this video, but hopefully I manage to make a video soon about RS2D. But this video is about a side project I've been working on. I've made a decent amount of progress on, but nothing too useful so far. So I'm just gonna give a quick introduction to the problem I'm trying to solve with this project. So some of you may know that some languages like Java or C Sharp or Python or TypeScript or pretty much any recent language like made after 1980, they have a garbage collection system. And what that means is when you allocate memory, it's automatically going to get freed eventually when you no longer hold a reference to that memory. So yeah, the pretty much whenever you call the memory allocator, it stores the memory. Whenever you equal to the pointer to the memory, it stores the reference. And when you delete an object, it decrements the reference count. And when it's at 0, it gives it to the garbage collector so that eventually it's going to get picked up. But the thing with the garbage collector is that it's async. And what that means is it's hard to do anything when the garbage collector is actually like called. So pretty much how it works in C++, which doesn't have a garbage collection system, and it's more easy to have a memory leak, which is when you don't free your memory after using it and you lose your reference to it. So essentially you're allocating memory, not freeing it, and your program is taking more and more memory, and that's why sometimes there's games that are lagging when you keep them running for a long time. That's one of the causes. But anyway, so in C++ you have destructors, and you have to explicitly call the destructor most of the time. And what I mean by most of the time is that, well, actually, just to put it in context, a destructor could be something like you give a, well, so the destructor is held by an object. When the object is deleted, you might want to free the memory. So the object itself, the memory of that object is going to be deleted when you call delete on it. But if that object holds some resources like allocated memory, it's in the destructor that you would free it. And so I don't exactly remember what the start of my sentence was, but pretty much that's what you do in a destructor, and you have to explicitly call delete. And yeah, exactly what I was saying is that it's not always explicit. What you can do is you can use shared pointers. Shared pointers is a way to represent a pointer as an RAII resource. R resource acquisition is initialization. Yeah, exactly, RAII. So RAII means you give an object the responsibility to do something in its destructor, pretty much. So the resource here in this case is memory, and the shared pointer is going to automatically free it. And what that means is that instead of your object allocating memory, you make a shared pointer that holds the memory. And that shared pointer is automatically going to be deleted when when the object is destroyed, and you don't have to call delete on the shared pointer because it's deleted. Well, let's not get into too many details, but it's going to free the memory. And so shared pointers is really the way to go if you want to make sure you don't have a memory leak. But the thing with shared pointers is that you have to type std shared pointer template with your type every time, and then when you want to make it, you have to do make shared, well, std make shared template with your type, pass the parameters, and it's a bit annoying. And so essentially it would look like this: std shared ptr keyboard language, let's call it like cat, cat here, and then you could do like cat equals std make shared cat, and then pass some parameters, which are emplaced to the cat constructor anyway, or like perfect forwarded. And so you have to agree that this is kind of a pain to look at, because if you were writing Java, you could achieve nearly the same thing just by writing something like this. And so what I wanted to do was a way to write this and transpile it into this. And at first it seems really easy, right? Because you think, well, I'm just going to replace every type with the shared pointer of the type, and every new with the type with make shared with dot, and that's it, right? But it's complicated to it's very easy to do exactly that, but you're probably going to end up replacing a bunch of stuff that you shouldn't have replaced, and you might even miss some for like, because essentially, ideally, I also want to remove the new invocation, which would be nice, but that might be a bit too complicated. So for now, we're going to keep the new because it's a good indication of what you're trying to do, because it's really hard to tell, am I calling a constructor or am I calling a function if I remove the new? Because in C++, this is a constructor, but without the new, it's hard for the transpiler to know. So I've just said transpiler. So what's a transpiler? A transpiler is a way to write a language in a higher level form, and you transpile it into a lower level language. Most transpilers, they transpile to like C or JavaScript, or that's pretty much like the only ones I've heard of. So for example, TypeScript transpiles to JavaScript, and the Python transpiles to C, for example. And Python is not C Python. C Python is the most used like version of Python. It's not version. I can't remember exactly what the word I'm looking for is, but essentially C Python is what people use for Python, and Python is something that looks like Python, but you have to transpile it to C, and then you can compile it too. So it's probably actually just transpile compile in one line. But yeah, so that means you don't have to write a compiler. So if you want to make a language, you don't need to make a compiler. You just need to make a transpiler, because the compiler for for C, C++, whatever, it's already optimized. So if you just transpile your thing straightforward, you're probably gonna have a decent result. The problem is if you have too much overhead in your operations, of course, even when compiled to C or C++, it's gonna take a while, right? But it's still going to be better than trying to write your own compiler, which would take years. So what I'm trying to do is transpile to C++. But if you wanted to transpile to Java, that could also work because it's simpler. So essentially, I'm leaving doors open to transpile to other languages. I'm thinking probably you could transpile easily. If you can transpile your program to C++, then you can probably transpile it to Java or C# pretty easily. The only problem is the destructor logic, which I do want to keep in my program. Anyway, let's not get into that too much. So the first step to doing something like this is, well, you need a way to read the program. So let's go over here. I've made a a program here, called it Curzy++. I didn't really know like if I wanted to put a name for the language, and I really wasn't going to put like a blank name for the project, so I picked my last name, and plus plus because I'm transpiling to C++, so why not? So yeah, let's see. So Curzy++ would be the transpiler name, and the language would be Curzy, probably something like that. And essentially what I'm doing is, the first step is you need to tokenize your program. So I guess I'll go over the entire thing pretty quickly, like what I'm doing just in the main. These test functions, you can forget about them, but essentially what you want to do is you transpile a file, so you read all of the file into a string, and that's your program, right? And then you just call the tokenizer with the program, and the goal is to output a list of tokens. And those are not just tokens, they're token values. So a token, in the sense of a compiler, transpiler, or tokenizer, or a grammar, is usually like a key element in the syntax. So it doesn't really hold a value, it's just like an identifier. So most of these are symbols. So if you look here, my token lookups here that I have, so the token lookup is actually used for debugging. So this isn't really any logic. But if we look over here, for example, this is where I'm tokenizing the program. So this is read token, right? And this returns the token, which is like the type of the token. So right now these are just enums, so they're integer values. And this is the value like string wise. So this is like the key and this is the value. So Now you might be thinking, well, shouldn't these two things be like one singular thing? And they kind of are because they are a token value, but the fact that they're not, that they're linked pretty weakly here is kind of annoying. But the reason for that is because not all tokens have a fixed value. Some of them, obviously, like words, well, a word is a token, but a word can be very like different things. So for example, a word could be one of the few keywords you have in a language, like class, return, new, switch, for. Any of these are keywords. So obviously the reason you can't call your variable class or whatever is because it's called a reserved keyword. Usually IDs will use the reserved keyword to indicate that. And then if it's not one of these keywords, well, it's whatever word you just typed and we just returned that word. And so you just have to go through the entire program, try to parse it, all of the operators, everything. It's quite a pain because if you make a mistake here somewhere, well, it's going to be really, really hard to figure that out. But hopefully I didn't make a mistake. And then once you do that, you just parse all of the tokens, you put them in a stream, and you output that. So that part is really easy. Now, once you have the program, the hard part is making sense of it because, well, it's really complicated because very similar sentences or lines might lead to different operations or, well, and you have to put it all into a tree. And anyway, so I made my own grammarizer here, and explaining all of this would take quite a while, but I'll try to go over it in less than 10 minutes. So the key parts of a grammar is that you want to be able to say that some elements are either like a composition of many different things or a choice between different things. So I think I should find an example to put this into context because this is very weird otherwise. So let's go into maybe a statement would make sense. So imagine a statement, right, in a language, like for example in C++, you can put expression semicolon. So expression might be like a function call, and then you finish your line with a semicolon, or it might be an if statement or a for statement, or it might just be a semicolon. You're also allowed to do that. And then you're thinking, well, shouldn't like if statement be a statement? So couldn't you say, well, it's going to be an if and then a statement? Well, yes, but that's the responsibility of the if statement. So if we go into if statement, so it's an and, so you need an if, open parentheses, an expression, and then you need to close the parentheses and then put a code block node. And then the code block, there it is. So the code block, well, it's brace open, and here this is bad. This is, oh no, this is statements. Yeah, okay. So a bunch of statements, notice the S here, and brace close, or it's just one statement. And I'm also missing something now you might have noticed. I'm missing an else. So here, if I wanted to do that, right, all I have to do is do something like this. So optional. And then here I need to put make else statement node. And now it's not going to work because I don't have an else. So let's go and add it. So let's go here, maybe class else statement node public node base ctr what. Okay, and then we're going to override build, and then what we're going to do is it's going to be else. I don't even know if I have that. I don't. So let's go add the token. So else, and then this if. So I have my token lookup here, I have to say. So token lookup bracket else equals else. This is just to print the value when I am debugging. And then let's look for the if again. It should be, yeah, of course, so it's going to be here. So now we're going to do this. If word equals else, it's going to be else. So it's really simple for me to add new keywords like that. Very, very simple. The symbols are a bit more annoying because if you look, for example, here, when I'm parsing a multiplication, for example, we'll have to check if it's like a times equal. So there's a bit of logic here, and it's a bit weird, but because pretty much this is just like copy paste of a bunch of different variations of it, and sometimes it can be like plus, can be plus equal or plus plus. So then you need to put an if else inside of this, so it's a bit annoying, but yeah, anyway. And then apparently here there's three things, so minus, yeah, the arrow, of course. Yeah, so parsing the operators was a bit more complicated than parsing the words, let's just say that. So here we're gonna have else, and then that's just gonna be a statement. Statement or code block? A code block. Yeah, there you go. And I think it's that simple, except here with no comma, and now it works. So now you might be thinking, well, what the fuck is he writing? Is this C++? What are those functions? They're purple. Well, those are macros. And the reason I'm using macros all over the place is because otherwise it's too long to type this shit. So let's go see which macros I added. So the first one is make, which just replaces std make shared with the template type. This is one of the few macros that actually takes a parameter. There's that, there's the constructor, which just sets the name of the node to the class name. And there's node class with this. Pretty much node class is only used like once. I can show you where because it's a bit, well, can I Control Shift F maybe? I think it's only used in one file, so technically I could even move it. Yeah, let's put it there, it's gonna make more sense. So it's because these expressions, it would take such a long file and it would be really hard to see how many expressions there are, or it would take multiple files and just for like no reason because each class is so small. So I made a macro just to define these more quickly. And now you might be wondering, well, how is it that he's defining a class in one line? Well, actually there's a missing part here. So you can see expressions, there's a header, but there's a CPP, and all of the build methods are in the CPP. So if we go look at the expressions, the thing with expressions is that it's kind of a recursion pattern. So if we start here, we have assignment expression, and then assignment points to conditional. Well, it's either really, well, so you see it's conditional, operator conditional. And then here, the conditional points to or, and then the or points to and then you go all the way down, okay? And on the last one, you see that here, parent, yeah, exactly. So the last one here, postfix, points to parent expression, and parent expression is actually just parent expression parent. So it points back down to expression, but of course you need an escape possibility, and the way that you escape this endless loop is by at the end of the thing either having like a word or a number. It's not only a word, it has to be a type name for me because, well, for example, if you're doing something like this, like A plus B F or something, I don't know, this is like, it's not really arithmetic in the sense of like a mathematical operation because, well, in math you don't just call functions like that, and this namespace operator doesn't make sense. So, but in programming it does. So to me, that's a type name. But the thing is, I think this type name might be wrong because, well, actually no, because this is postfix. Like, pretty much what would happen is that this would be a type name. This would be also a type name, but it's really just a word. But it's still, to me, it still matches as a type name. So the only important thing is that it does match something. And then this is a postfix operator here. So it would be, as you can see here, it would be a parent expression, and then an or, and then here you have parent arguments node. And parent arguments node, Well, it's pretty much exactly what it says. It's parentheses, and then there's an inner arguments node. It's just a bunch of expressions with commas in between. But it can be 0, so here it's just 0 of them. So, well, I hope that made sense. Yeah. Let's go back to the macros. So as you can see, I have some other macros like and, or, star, plus, optional. Well, I guess I can show you these nodes because they're very interesting. So let's open this and this. So these are the most basic nodes. Yeah, these, and there's one more. So the and node represents an and it's the one that calls and from the grammarizer. So most of the nodes, they just called build on the grammarizer with their nodes, but the grammarizer, oh no, they called build and they pass, well, whatever. Okay, I'm not going to get into too much detail, but pretty much the grammarizer offers the and or, and it also offers access to the tokens and the iterator. So most of the things you're actually interacting with the grammarizer for are calling and, calling or, and you only really check the tokens in, well, it does make a lot of sense inside the token node. So let's go into base, and I have here token node. And this is the only one that has like a weird build function. So here, don't worry about this underscore build and whatever, it's just because if I'm debugging, I log a bit more stuff, but I just end up calling underscore build instead of build. So here, the token node, I parse for every like unwanted character. I add them to my stream. Here, value plus equal. It's not a stream, it's a string, so it's not really efficient to do plus equal, but I wasn't going to make a string stream just for that. So anyway, I could have. I really should, because every time I look at it, I think it should be a string stream. You know what? Let's do it. STD string stream, and then let's do stream git second, and then here if I return true, I guess I'm gonna do value equals stream dot str. Yeah, that was not too bad, was it? So, okay, exactly. So as you can see, the token node interacts with the G, which is a grammarizer, and it looks at the iterator, which is a token, and it's trying to find the token you're looking for. So you initialize the token node with the token, and you just parse until you find it. And if you find it, well, is t is going to be true, you're going to return true, and if you don't find it, you end up not matching the statement, so git first, which is the token, it doesn't match any of these things. Well, you didn't find it, you ran into something unexpected, so you just return false. Nothing too crazy, right? So let's go back. So the token node, as I said, this is the only one that has like a weird method here. Most of them are really simple. So for example, here build, it just calls and, it just calls or, and if you go look at other ones, it's a bit more interesting because they don't even have the build with the grammarizer. So let's go look, for example, I'll go back to the statements node. As you can see, this build here doesn't have a parameter. Now you might be wondering, well, so there's a build with a parameter, there's one without a parameter. Well, yes, if we go into the node class, it actually defines a method here with the grammarizer. And what it does is it just calls build, and then it does return, get the first node of my nodes, and call build with the grammarizer on that node. So each node is calling build with the grammarizer, and eventually the node is not going to call this method, it's going to call an overloaded method. So either the one from token or and. And yeah, so the reason I have the and or nodes, well, not just because it's fun, it's actually because they encapsulate a very important dynamic. Well, here, this and method, you can see I'm storing the iterator in temp, and if I can't manage to parse the entire thing, I will reset it and return false. And this is a very important dynamic because when you're parsing the most important thing is your iterator, and you don't want to lose it. So this is the only thing that touches the iterator really. There's this, and there's the token node. There wasn't really a way for me to do it with the token node any different way than giving control to the node. So the node also touches the iterator, but yeah. The thing with the node touching the iterator is that the node can't really mess up the iterator because the token node is called from like inside the AND node. So what happens is that the AND node, for example, is going to call build with the token node. Token node is going to mess up the iterator, and this is going to fix it. So the token node can do whatever it wants with the iterator because as long as it returns false, this is going to get like reset. And now you might be thinking, well, what about the OR? The OR isn't resetting it. Well, the OR, it doesn't really matter because OR probably calls AND 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 resets it. So the OR doesn't have to care about it because if all of these return false, it means the iterator isn't changing. So whenever you call build, you're always starting from the same place. I don't know if that made sense. But with the AND, it does work. It has to work multiple times in a row, and each time it works, every time it works, it changes the iterator. But when it doesn't work, it doesn't change it. So the thing with the OR is that if it doesn't work, if it works, it just has to work once and it returns true. But the thing with the AND is that it might work, and then fail. So now your iterator is not in the right place because you just made it work twice in a row, which increments the iterator, unless it's an empty node, but most of the time it's not. And then in that case, you have to reset the iterator when you reach like the nth element. So yeah. The token nodes. Yeah, these K nodes are pretty interesting. So if you're looking at regex or expressions or stuff like that, like in transpilers, you're probably going to need to implement something like the fact that a character is either optional, can be there multiple times in a row, can be there multiple times in a row, but has to be there at least once. And those are usually stars, pluses, and question marks in regex. So the star is can be there as many times as you want. The plus has to be there once, but can be there more than once. And the question mark is 0 or 1. So what I did is I made a class KNode that represents this dynamic. So essentially what it does with this build here with the grammarizer, as you can see, every time it tries to just make a node with this builder, so you initialize the KNode with a builder. The builder creates a node, and you try to build this node. If it does build, it works, you add it to your list, otherwise you break. You just fail to parse whatever thing you were meant to parse, you fail, and then you return condition. And the condition here for the star, condition is true, because there's no condition with the star. It could be there a million times or 0 and it would work. But for plus, the condition is that it has to be there at least once. And then for opt, it has to be there at most once. So those are very basic classes, but you can see how concise they are because of this logic here. And the key really is to pass the node as a function that returns a node. Yeah. So I guess that's kind of like the entire structure of what I'm trying to do. And now you might be thinking, what, all of this, all of this just to replace the new constructor operator to a shared pointer? Well, yes and no. When I started going deeper into this, I was thinking, hey, there's probably a way for me to implement compile time decorators with this. What I mean by that is that you might be able to put some decorators, so usually in Java that would be like at async or whatever, and then you could put like parameters in there. So that would be like a decorator. They put the question, the at symbol to represent that. And so I'm not sure, I would probably just go with the at symbol because why not? But what you do with that is you run code kind of like, I think it's probably when the object is created, but it's also, I'm not sure exactly what the scope of these annotations are, but I know that some of them can mean that objects are created without you creating them. So for example, you can like at bean or at stuff like that with Spring Boot and beans, and it's just gonna like create them. So somehow there's some classes that have access to these annotations and can access them, but that's not really what I'm trying to do. All I want, well, maybe eventually, but all I want for now is to try to implement some simple design patterns with these decorators. And if that does work, then that'll be really nice. But yeah, so there's a few things, right? So there's replacing the new to shirt pointers and replacing and adding some base design patterns kind of like implicitly with these things. So that's going to be very interesting. And the strength of this is that I decide my syntax. I own the transpiler. I decide what I compile into, and the language is going to be similar to C++, so the transpile isn't going to be too complicated. I'm not going to go into crazy mechanics that Java might offer or whatever. If I can't transpile into Java, I don't really care. My main goal is to transpile to C++. And yeah, I know I spent like a lot of time on this, and it kind of sucks because I wanted to work maybe a bit more on RS2D, and I kind of had motivation, but at the same time I feel like I want to finish this first. But the thing is that projects like this, like these, can take like over 100 hours easily, and you don't feel like you've really accomplished anything. So right now I've worked on this maybe like 50 hours. But the problem is I started playing League of Legends and I spent way too much time playing League. So I don't really have that much time to work on this, but I don't know. Maybe I can find some time during the semester, but that's really hopeful because during the summer you should have more time than during the semester. And I'm gonna have a project this semester, but it's also my last semester for my bachelor's, so might have a bit more time because I'm not probably not starting a job right after. I might be doing a master's, so that would give me a lot of time for um, like personal projects because my master's is going to be highly related to design patterns. So if I can get more familiar with implementing them, that might be a really good idea. Because the thing with design patterns is there's always more than one way to implement them. Recently, I read an article about implementing design patterns with templates, um, and that was really interesting because I really didn't think of that possibility even. But essentially, if you it's like replacing inheritance with templating to make your code more well, it's like you remove the use of the virtual table so the calls are faster, but God, it's like such little things they're trying to speed up your program on that I don't even know if most people would use it because it does make it harder to read. So yeah, anyway, there's always some fun ideas around. It's kind of meta programming because programming usually in like engineering, whatever, it's like, hey, I want to send this message to this machine with this protocol. Can you do it? It's not working. SSL isn't working. Blah blah blah. Permissions. Spring Boot. Okay. OpenShift not working. And then you're like, am I even writing code at this point? It's always like a different technical problem that you're running into. But design patterns abstract all of the uses for them. It's only like theory that like you should design your code in this way so that you don't have to spend as much time redesigning later and working around flaws that you've introduced, because the design patterns make it so that you follow like the standard guidelines for designing code. So I do think they're quite interesting because software as an like engineering field, most of the time it's done like very quickly, not much thought into designing. If you look at people who like show their progress on projects on YouTube or whatever, like most software stuff that people see, it's done by amateurs, right? They don't really care about if their program is good. It's only like a few lines, a snapshot for a program, whatever. You never have the full context, but in big projects, you cannot possibly think that you're going to manage to have a team of people working on their own solutions, their own patterns, not validating them with the team. And that's where like design patterns come in because it's like a standardized way of speaking about software components. So I don't know, maybe one day we'll just have diagrams of patterns pointing to each other and that'll be it. And yeah, I do think that one thing that kind of sucks in the current state of technology is that most people they provide technology, but they don't provide enough code to connect to their technology. So, for example, you want to connect to a database or whatever, and then you look like, how do I connect to this database? And you find like example for one language, and then for another, it's like completely different. You need to pass different credentials. It's like, well, how the hell? And then you find out that actually what you're using is a library by a third party to connect to this, and it's like, well, why the hell doesn't this thing, this like association create like standardized code to connect to my thing? It would save everyone so much trouble. But no, you just have to look for through like 100 different solutions until you find the right one. So I do think that's one of the bigger problems in programming right now. But I don't know. One of the ways I intend to approach this with my code is that if I do finish my transpiler, I'll provide a bunch of utility functions always included in the program. So, for example, when you're writing Python, you want to open a file, easy, you just call open, you put the file name, it's open. In C++, you want to open a file, well, good luck, you're going to get a fucking headache. No, sometimes it's fine, but sometimes it's really annoying. In Java, you want to open a file, great, you need the try catch, you need a file reader, then you need to make a buffered file reader with it, and then you need to close the file reader when you're done. Forget one of those things, it's going to tell you that your function is not throwing something, that you have to add the throws declaration. And then you try to close it in your finally, and then it says, well, it might not have been initialized, and then you need to put a try catch in your finally, and it's like, wow, why the hell? So I do think I need to provide a bunch of wrappers for various very simple operations so that they can be used very easily. And I do want to try to work kind of like a plugin architecture where clients of the language would be able to replace some implementations of my functions with their own if they think they're better. And then they might be like different distributions of my program. I wouldn't really mind. But obviously, I don't think it's going to get that far. I just think I'm going to work on this for a while, forget about it. No one is ever going to use it, and that's going to be it. But realistically, if I can finish this project, it's going to be really good for me. So just going to keep working on this for now, and I hope you enjoyed the ramble. Out.